So this is the predictive main page of our predictive asset intelligence application, which is designed to cater to the requirements of multiple personas in the plant. For example, this is the main page of application which is meant for a regional manager or an operations head of company. Here they can see the health score of all the plants at enterprise level. They can see a health score or trend here along with the critical assets and some alerts from the different plants which belongs to that particular enterprise. In from here we can drill down to any one of the plant to see how that plant is performing, how it is health score, and so on. In fact, one can drill down to each level of asset hierarchy here to according to the need of that persona. Each level of hierarchy here has its own configurable dashboard with various widgets which themselves are configurable and are built for industrial use cases. So you can see, for example, here this is the health score of a boiler feed pump. You can also see some asset documents you can attach here. You can see a performance curve. You can also attach some vibration reports. You can attach some oil reports for anyone to see on this dashboard. You on this side, you also see what are the alerts. This is alert summary of different level of alerts on this particular pump. Now, so let's take a deep dive into what is this health score. So this health score is like it's like a stock index. It's a combination of various components of your asset health. These components could be indicator of mechanical condition of the asset, such as vibration level, oil purity, or the amount of wear and tear. But they could also be derived from first principle models or machine learning models. And combination of all these component is flexible and entirely up to the end user. So here, for example, we are giving 60% weightage to the oil analysis and maybe 40% weightage to the vibration health. You can change this combination. You can add more components to it to get a holistic view of the health of this particular asset. This type of index we can build for each asset of this hierarchy, and it can roll up to higher level to give you the health score for a plant or a system and so on. Now, another important aspect of our predictive asset intelligence application is its ability to receive alerts and alarms when there is an impending issue to be mitigated. For example, here we see an alert or an anomaly is detected on this boiler feed pump, and you can go into the details of this from here. Now, while such an early warning is useful, however, for an alert to be really actionable, there has to be some way to determine the cause and recommendation of issue or the actions to be taken to mitigate this problem. Now, our application does that autonomously by combining the output of these AI models with FMEAs to provide explainability for each and every alert. In addition to, so you can see here uh, for this alert, the cause is that there is a drive and temperature, bearing temperature is going up, and then recommendation is to maybe monitor it, inspect the bearing if abnormal. You can add more recommendations by expanding the FMES to include more recommendations and more causes. In addition to providing this cause and recommendation for alert, it also gives user all the features to assign this alert to their team members to, let's say, investigate. They can write comments here. They can see history of the alert. They can attach reports, or they can attach the pictures from the field, or any other reports here, maintenance logs here to conclude the investigation of this particular alert. Now, this predictive asset intelligence, as I said in the beginning, uh, it is designed to cater to the need of multiple personas in the plant. What we have seen so far is the use for a, say, a maintenance engineer, or for a plant manager or a reliability manager. But it also provides tools for a subject matter expert or a data scientist to dig deeper into the AI model output to ensure that no one is running a black box that is not explainable or not trustworthy. Here one can see how this app provide an interface to interact with the factors that are contributing to this particular alert. So in this case, this particular alert, these are the contributing factors for this alert, and you can see in what proportion they are contributing to the alert. User can click on this. User can see how the that particular sensor data is trending. They can zoom in or zoom out to do more to analyze the data more and so on. Now, uh, to achieve the explainability, each point of this anomaly detection engine comes with a set of contributing factors. So as I said in the beginning, the AI algorithm runs continuously in real time on the data, and it generates the anomaly score for every data point that is received from the sensors. And for each data point, you click on it, it can show you uh, what are the contributing factors, and you can see the trend of those. So this way, predictive asset intelligence can satisfy to the needs of various personas in the plant, be it plant manager, be it a maintenance engineer or a data scientist or a subject matter expert. So with that, now further with the help of generative AI Copilot, the end user such as maintenance engineer or a plant manager can interact with application in their natural language to understand their asset performance, to compare their assets across the plants, to investigate the alerts, or to perform and scenario planning to get best performance out of their assets. And all of this can be done with just a few clicks from user without the need to navigate through the application. So for example, here I am showing you a Copilot. So let me kind of launch it. So the Copilot is here. You launch it like this. You usually get prompts, or you can write your own question here. For example, I'm saying list all the anomaly detection alerts for this particular asset during this period, and then I get the list of a list of alerts here. Then you can say perform detailed analysis of alert for a alert number 651, let's say. So this Copilot then look into the database. It kind of combines all the information that is available, and it gives you a summary of the analysis of why that alert is occurring. What is the alert ID, when it happened, what are recommendations, cause, what are the contributing factors, and so on. Now, we have also integrated predictive AI models, forecasting models with this Copilot. So you can also ask for on-demand plot of any particular parameter or a forecast of any particular channel. And once you have done your investigation on this, or you've done your planning on this, you can simply click on this PDF button here to generate a report to generate the report of this analysis. So this is how this generative AI Copilot can help your people to boost their productivity by otherwise any investigation of an alert, preparing a report might take few hours of a maintenance engineer's time. While here, this can be done in 10 minutes by just writing your questions in natural language.